and conditional probability. So for 711, we're going to explore, conjecture, and prove. And we're going to answer the question, what can I learn about quadrilaterals? So Carla knows that a parallelogram has two pairs of parallel sides. She has studied special properties of isosceles triangles and right triangles, and she wonders if parallelograms also have special properties. She remembers that it's possible to create a quadrilateral that looks like a parallelogram by rotating a triangle about the midpoint of one of its sides. Okay, so the first thing they want us to do is rotate the triangle about the midpoint. So they gave us the point and make a quadrilateral that looks like a parallelogram. So if you had tracing paper, and some of you do, but if you do, great. If you don't, you can just watch me do it. So we're going to match up the triangle and trace it here. So we're going to trace that triangle. I even drew the midpoint. If I rotate it and I put my finger right on that point and turn it, that's a rotation, we're going to have the double arced angle right there, the single arced there, and the double tick mark there. So that's going to create a parallelogram for us. All right, that's part A. Part B says, is Carla's quadrilateral truly a parallelogram? Use the angles to convince your teammates that the opposite sides must be parallel. Then write a convincing argument, okay? Because we are matching up the angles, we are going to say that yes, it is a parallelogram. We end up having alternate interior angles and opposite sides end up being parallel. Part C says, what else can the congruent triangles tell you about the properties of a parallelogram? Look for relationships between the angles and the sides of the parallelogram. So opposite angles will end up being congruent and opposite sides end up being congruent. Page 2, we have question 7-2, which says that the definitions are one of the building blocks of geometric proofs. For example, by definition, a parallelogram is a quadrilateral with two pairs of parallel sides. You can use this definition of a parallelogram or any other polygon as the starting point for proving other properties. Part A says, does the diagonal of a parallelogram always split the quadrilateral into two congruent triangles? So we're going to look at ABCD right here. It says, if ABCD is a parallelogram, what do you know must be true from the definition? They want us to mark the diagram appropriately and then write a flowchart proof to show that the two triangles are congruent. Okay, so we start with this parallelogram, which is the outside shape, the ABCD, but when we draw the diagonal from B to D, it creates two triangles. So we have triangle ABD over here, and we have triangle CDB over there, okay? So the first thing in this proof that we're going to start with is the information that they give us. So the information that they're giving us is that ABCD is a parallelogram. We call that the given information. Okay? So what do we know about parallelograms? We know that their opposite sides are parallel. So the top and the bottom are going to be parallel. That's AB is parallel to CD, and the left and the right are going to be parallel. So that one's AD and BC. This is by what we call definition, because the definition of a parallelogram is just that its opposite sides are parallel. hence the word parallelogram. It has parallel right in it. Okay? Once we know that, we can conclude that the angles created by having a diagonal drawn in are going to be congruent as well. So this tells us we're going to draw in this diagonal right here, BD, and BD happens to be congruent to DB. BD, DB, they're so close, okay? All right, that gives us angles. So the first angle is ADB. So from here to here to here is congruent to CBD, is this one right here. Those are alternate interior angles that we learned about last semester. And the other two pair, the ABD and the CDB, are also congruent. That's by alternate interior angles. So what that does is it creates congruent triangles. We have parallel sides, which creates congruent angles, and then they share that side in the middle. So we say that they are congruent by angle side angle, one of the 5 congruence choices that we have. Okay? Once you prove that the 2 triangles are congruent, you can say that their corresponding parts are congruent. We call this CPCTC, which is corresponding parts of congruent triangles are congruent, which is a lot to write out, so we abbreviate it with this CPCTC. Kip is confused. He puts his 2 triangles from problem 7-1 together as shown at right, but he does not get a parallelogram. Okay? Part A says, what transformation did Kip use to form his shape? So instead of rotating it like we did with the tracing paper, he actually reflected the triangle across one of its sides. So part B says, see the definitions of the polygons in the math notes box, which we already read, and what shape does Kip make? So he happens to make a kite, because if you look at the definition of the kite on the next page, it says it has 2 pairs of adjacent sides that are the same length. Okay, so this side and this side are consecutive, and they're the same, and this side and this side are consecutive, and they're the same. What do the congruent triangles tell you about the angles of this polygon? Justify your answers. Okay, so the kite has at least 1 pair of opposite angles that are congruent. Definitely not at the top and at the bottom, right? It's going to be the 2 side ones. And then D says, what do the congruent triangles tell you about the diagonal of this polygon? That the diagonal bisects the pair of opposite angles, and that they are not necessarily congruent.